Welcome, developers. Welcome to this first installment of what I've called Programming with SimConnect. You can see it as an explanation on writing C and C++ applications that talk to Microsoft Flight Simulator using the SimConnect SDK. The focus will be more on C++ than C, but, as I hope to make clear later on, that choice is partly forced on us as SimConnect itself uses C++. In this first lesson, we'll discuss what you need to use SimConnect, go through a simple Hello SimConnect application, and improve on it using a C++ library. Of course, I have my own style of writing such code, and I hope to make clear to you why I do things the way I do them. All the sources that I show, as well as any supporting code and libraries that I use that I've written myself, will be available on GitHub. Although I will use Microsoft Flight Simulator 2024 to demonstrate, a lot of what we'll do works virtually without change with Microsoft Flight Simulator 2020. In fact, if you have them, Lockheed Martin prepared, as well as the old-school Flight Simulator X, which is still available on Steam, will be able to support most of the basic stuff without any issues. As the YouTube tradition now phrases it, without further ado, let's start. What you need is a Windows PC with the simulator installed on it and the SDK. I use Macs and Linux systems for development as well, but for SimConnect, unfortunately, Windows is required, not just because of the simulator, but also because of Visual Studio 2022, which is prescribed, advised by Asobo. You can develop on a second PC if you want, and SimConnect allows you to connect to the simulator through the network, but it will make debugging more complex. So, for simplicity's sake, I suggest just use one PC. CPU and memory are more important than graphics while developing, and traditionally also while running the simulator, although that might be changing in the future. My own setup uses a fairly recent Intel processor with 32 gigabytes. 16 gigabytes might be a bit tight, especially if you want to run the development environment at the same time as running the simulator. I have an older graphics card which actually works fine. It's just an NVIDIA 1080. Microsoft 2020 was pretty lenient with respect to the hardware requirements. 2024 now sets my settings immediately to the lowest possible, but it still looks quite good, so I don't mind. And to be honest, prices for new graphics card are at this moment simply ridiculous, so there's that. First of all, download and install Visual Studio 2022. Make sure while you install it that you select CLang and WASM support, because they are needed for some of the plugins that you can write for Microsoft Flight Simulator. Those are actually not SimConnect plugins that we're going to talk about, but you will need them if you want to continue. Microsoft Flight Simulator 2020 requires Visual Studio 2019, but it will work with 2022 added to it. So if you have 2020, you'll need to install Visual Studio 2019 first, and then 2022 on top of that. If you only have 2024, leave out 2019. Install the Visual Studio build tools for Visual Studio 2022 because they give you a very useful add-on tools. Forget you have 2019 and always run 2022. I could make a more detailed video about installing Visual Studio in the future, but I think it's pretty self-explanatory, so I skip that. In Microsoft Flight Simulator, go into the settings and enable the developer mode if you haven't done that already. It then has a help menu, which you can see at the top if you move your mouse to the top of the screen, where there are download links for the SDK documentation, and the samples. If you install the SDK before you install Visual Studio, the installer will not find Visual Studio and not give you the templates that you can use for WASM plugins. Okay, let's start by checking to see if we have what we need. We'll make a simple Hello SimConnect application. As part of this, we'll touch upon the basic settings in Visual Studio 2022 for these kind of programs. Note that these are my recommendations, they're not absolute requirements. Also note that I'm pretty harsh on myself with respect to the standards followed. I myself prefer to use the latest fully supported versions of C and C++ and a higher settings for warnings and errors. You may also notice that we're not creating a C project. Visual Studio 2022 actually no longer offers that as a choice. If you do want to use just C, just create a C++ project and use an empty project and then create your C programs with the C extension. This will cause Visual Studio to use the C compiler instead of the C++ compiler. But we'll get back to that while we make our hello world, because for SimConnect there might be some unexpected effects. Actually, most of the time C++ will let you do the same as you do in C, and some things even better. So let's go to Visual Studio. Okay, welcome to my desktop. Here you see I've prepared a command line console where we'll run the application. So let's start by running Visual Studio. We're going to create a new project, and we can now select a template on the right. You see here on the left first, we can select the language. There is no C, so we're going to choose C++. On the platform side, we will select Windows, but first you'll notice that Microsoft Flight Simulator SDK has inserted a few templates. These are WebAssembly templates, and they are meant for writing plugins that will run inside the simulator. We're not going to do that. We're just going to run a console Windows application. We'll create an empty project, and let's start. Give it a nice name. Okay. Well, an empty project. So let's add our first source file. We'll call it main because it's the main function of our project. Give it a nice explanatory comment to start. And then add the main function, because that is what will get run. We can give it 2 parameters. For the command line arguments, we're not going to use them, but they're standard, so let's put them in here. And we'll start by just returning 0, meaning that the application ran successfully. Okay, we want to connect to the flight simulator, so we need the SimConnect header. Let's add an include for SimConnect.h. Now you see, of course, red squiggly lines because it doesn't know where the header is. So we need to change our settings. So we go to Properties, and we'll start by some general settings, because you see that by default it chose a very old version of C++ and C. And let's just make that the latest supported version. Apply those changes and go to the C and C++ page. Here you see that we can also change some other things. Let's set the warnings as high as possible, because we want the compiler to warn us if we do anything unusual, and actually we'll want any warning to be an error, so it fails the build. That's just good practice. Then we need to add the include directory for SimConnect. So edit those and choose a directory. We go to where Flight Simulator is on my PC. Here's the SDK, open that. Then SimConnect SDK, go into that, and here we find the include directory. This is what we want. Okay, apply, close. Now, this means that our include file is now found by the compiler, and you see that if you press Control, you can Control-click it to open that file. And now you see that, unfortunately, SimConnect itself still has lots of errors. This is because it uses some standard defines from the Windows headers, and we need to add that. So let's add an include for windows.h. This is all documented, of course, in the SDK documentation. Now, if we go back to SimConnect, all the red has disappeared. Good. That means we can now build our application. So we press F7, and we get lots and lots of messages. This is because, unfortunately, the Windows header files are not as clean as we want nowadays. They are a bit old, but changing them will break a lot of software. So what we can do is tell the compiler that we need to reduce the warning level while it's looking at these header files. So we say push the current settings and switch to level 3. Then when we're done with these header files, we can go back to our previous settings. Okay, fix that typo. If we now rebuild, we still get errors. Unfortunately, level 4 also causes, or level all causes problems outside of those header files. So let's go back to level 4. I've tested this, and this is the highest level that will work with these header files. Apply the settings, close, and now if we build, we only have 2 warnings left, and those concern those arguments, command line arguments that main can receive that we're not actually doing anything with. So here you see the advantage of having a high level of warnings, because we're being warned that we have something that we're not using. We'll just tell the compiler not to worry about that. And this causes us to get a working build. Okay, we want to open a connection to the flight simulator. So let's make a test function for that. It's just a local function, so no need to export that name. And now we're going to make a call to the first SimConnect library function. All library functions have names that start with SimConnect underscore, and we want to have SimConnect open. You see that Visual Studio gives us a list of the parameters. We need to start with a pointer to a handle, which will be used by the library to identify this particular connection. We'll call that hSimConnect for the handle to SimConnect. We'll define that later, then add the name of our client application. This is something that SimConnect can use to give an overview of all currently connected applications. It wants a handle to a window. We'll just use a null pointer. Index for a user message, we'll just use 0. Then a handle to a Windows event, again, not using that, so null pointer. And a index in a configuration file that we're not using, so again, a 0. Great. Let's add that handle. We'll just put it at the top. We're not going to use it beyond this test function at the moment, but we can use it in other functions if we put it here. And of course, it's good practice to make sure that any variable we create is initialized. Now, SimConnect itself will return a value. You see here in the flyover that it will return a value of type HResult. So let's capture that. And then in the SimConnect header, there is a useful standard macro for checking whether or not that means successful. So let's test if our call to SimConnect is successful. And if so, we're going to tell the user about it. Just use the standard output, which of course is not yet known to the compiler. So we'll add the include file for that. This is a C++ standard include file, so it doesn't have a .h at the end. And of course, if this fails, we want to show some kind of error message to the user. Okay, then because this is all we're going to do, after successfully connecting, we'll close the connection. So we make a call to SimConnect Close, which wants to know the handle of the connection, so it knows which connection needs to be closed. We'll tell the user about it. And we'll return the result of this. Well, this is a complete application. All it does is connect and then disconnect, but still, this should run. Let's add just a small welcome message. Okay, well, that was, of course, to be expected. We have the header file, but we don't have the library yet. So we need to add the library to our project. So go back to the properties. And this time we go to the linker section. Here we need to first add the directory where our libraries can be found. Just like previous, we'll select here the library directory, go back to the SDK, SimConnect SDK lib, and we'll take the static libraries. And then, of course, we need to tell the linker what it needs to pick up from there. So we're now going to add the libraries. Let me get those. This is, of course, well documented in the SDK documentation because it's not just SimConnect, but also a few standard libraries that we need to pick up. And because we're doing a debug build, we take the debug library. Apply that, and now if we build, it succeeds. So let's see what happens if we run it. Let's go into the solution directory. Here you see that we have a directory for x64, which is the Intel 64-bit architecture. There we have a single directory for the debug build. And here you see our executable. So let's run that. And of course, it failed to connect to Microsoft Flight Simulator because we haven't started the Flight Simulator yet. So let's do that. This takes a while, so let's skip a bit.
A few minutes later.
Okay. Flight Simulator has finished starting up. Let's go back to our command prompt. And you see it's successfully connected to Microsoft Flight Simulator and then disconnected. Hooray, our first application worked. Okay, welcome back. So there have been some things that I skipped over during this, but first of all, I hope you'll agree my code looked fine. We've done some stuff in C++ rather than C, but that's simply because with C++ you can do a lot more than C, and it's not just the classes. Using C++ allows you to write safer and cleaner code. Actually, the SimConnect header file that is part of the Microsoft Flight Simulator SDK uses C++. If you take a C file and let it include the simconnect.h file, you will find that the compiler actually throws errors. This is because some of the definitions for structures within it use inheritance, which is only possible in C++. The SimConnect API has a long history, and I think I'll make another part about that sometime in the future, but mostly that is why Asobo didn't want to make too big changes, I think, in the current API. Now, about those warnings, I set a high warning level by default. I think this is a good idea because I want to see as many warnings as possible because they are what we nowadays call smells. They tell me that there might be something wrong with my code. And there's nothing wrong, actually, with making sure that all those warnings are gone. They make my code better and easier to understand and safer. So the compiler is my friend, and it's a second pair of eyes that looks at the code that helps everything improve. So I appreciate those complaints. Now, you will also have noticed maybe that when we ran the build, that we got some linker warnings. This is because when you build for debug, you get code that is easy to single step through. To do this nicely, the Visual Studio compiler actually generates a database with information that is used during debugging. This is put in a PDB file, and this PDB file is not available in the Microsoft Flight Simulator SDK for the SimConnect library, even though there is a debug build lib file. So if you link to the debug lib file, the compiler, or at least the linker, will complain that it cannot find the corresponding PDB files. I'm not complaining about that because I'm not single-stepping into the SimConnect library. So during linking, the compiler complains about it, that it cannot find those PDB files, and will just ignore that. There are property sheets that you can use. They are distributed as part of the SDK. I haven't used them. I actually defined the linker path and library path, and also the name of the static library, or all the libraries that need to be included by hand. You can use this property file, and then everything is set for you. Unfortunately, the current version of the SDK has property sheets that have bugs in them. I'll put a copy of the ones that I have fixed in GitHub, so you can take a look and maybe they will work with you. The most important difference is that the property sheets are currently using an environment variable that was used with the 2020 SDK, whereas they are part of the 2024 SDK, and there is a new environment variable that you should use there. So my fix simply renames that variable in the property sheet. So now let's move from C to a real C++ version. We're going to create a base class for the SimConnect connection and call that a connection. It will get fields for the name of the connection that we need to pass to SimConnect Open. And it will also get, of course, the handle for the connection. And then it also gets an hResult field that we can use to record the result of the last call to SimConnect. However, the SimConnect Open call actually supports different scenarios. There were a number of parameters that we just left at null pointer and 0. What those parameters are for, we're going to discuss in part 2. But it does mean that we have different types of connections. So we will have different subclasses of our connection class. We're now just going to create a simple one, and we'll call it Simple Connection. Okay, let's start Visual Studio. Here you see the app we made previously. Now let's go to a prepared example. Here you see that on GitHub I've provided 2 projects, one for C and one for C++. The C one is actually using the sample program from the SDK. We're now going to open the C++ sample that I made. And if you look there in the OpenClose file, you see that we have a very simple application. It's doing mainly the same things as before, but it's now using the Simple Connection class. It's giving this application the name clean OpenClose. And on this SimConnect object, we can now call a method called open. It returns a Boolean. We're not passing it any parameters. There is one parameter, we'll see that later on. If the call to open succeeds, then we print out a message and close the connection and print out another message. And just as before, if the connection failed, we print an error message. Then you see here that we actually put this all within a try-catch block. And there is one type of exception that we can expect here, which is the SimConnect exception. If we get that, we print out the message from it. And finally, we return the current status of the connection. If the connection is In good state, we return a 0 and otherwise a 1. Let's go to the simple connection object. Okay, you see that it's an extension of a connection class. We have two constructors, one that will use a default name and one that will use a name that we can give. Since there's no additional fields in this class, the destructor is empty. We have a copy and move constructor that we have deleted and a copy and move assignment operator that we have deleted. We only want one connection object and not multiple copies of that connection object. And there is only one method, and that's the method called open. It can receive a configuration index number, which was the last parameter in SimConnect open, which defaults to 0, and we pass that on to a method called callOpen, where we give it the usual suspects as before. You see that we return a bool, and also this method is marked no discard. This is a compiler option that makes sure that if this method is called and its result is not used, then the compiler will generate a warning. You should always check whether or not you have a valid connection. Let's go to the base class. Okay, scroll up here. We have a number of fields. There is the client name, there is the SimConnect connection handle, and an hResult value for the last result. There's also a request ID, but that's something for the next part. Then we have a number of accessor methods, so you can retrieve the name, const no accept, always safe to do that. It's also marked no discard. Then we have a method is open, which will simply check whether we have a valid handle. The assumption is if we have no connection open at the moment, the handle is set to null pointer, and otherwise, if it's not null pointer, we have a valid connection. Then you can get also the hResult. Of course, we also need to be able to set the hResult, so there is a method for that. So any SimConnect call we make can store the value in the connection. Then we have, of course, a check whether the connection succeeded, just as we have a check whether it failed. Then below that we have the callOpen method that we called. It has here all the parameters that we passed, the usual ones, the window handle, the user message ID, the Windows event handle, and the configuration index. This is just as in the previous program. Then we have is open, which is checked. If the connection is already open, we're not going to do anything. And then we call SimConnect open, pass it the reference to the handle, a C-string of our connection and all the others, and we store the result in our HR field. Then we check whether we have one specific type of error, which is invalid arg, because if that happens, then our configuration index was a number that is unknown, which means we have a mistake in our configuration files, and that is a serious thing. So that warrants an exception. If it's not that, then we return whether or not the call succeeded. Further down, we have the destructor, which closes the connection if it's still open. And it's protected to make sure that it is called from SimpleConnect. We have the constructors. Here we have the name, the default name for the client. And we have the same deleted constructors and assignment operators. We have a conversion operator to handle. So if we use the connection in a place where we expect a handle, we use the SimConnect handle. We have an assignment operator. If we assign an H result value to the connection, it is stored in the HR field. And we have also a conversion to bool. So if we use the connection where a bool is expected, we use the succeeded method. Fetch syntax is for the next time, but here we have close. Of course, we only need to close it if the connection is currently open. In that case, we call SimConnect close with our handle, and we make sure that the handle is then set to null pointer. If this handle was not correct, which is the only documented error possible for SimConnect close, then again we have something very strange happening, because we thought we had a valid handle, but the handle is said not to be valid. So let's throw a SimConnect exception, because this is too strange. Close itself doesn't need to return, because you either have an exception or you have a closed connection. What's further down is for the next part. So that finishes up our connection class. Welcome back. If you're not used to exceptions, see them as a way out when things go really bad. They will exit the function or method that you're in, like a return statement, but they will keep returning upwards until they're caught, which you saw us do in the main function with a try-catch statement. Of course, this does mean they have an extra cost, because the compiler needs to take the possibility of an exception happening into account. However, they are very useful. So the default assumption for the compiler is that an exception may be thrown. As you already saw, you can mark a method with no except, and it's good form to do that, especially if you're certain that it will not be thrown. The compiler will help, because if it sees you call a method or function that is not marked no except from a method that is marked no except, it will give you a warning that you're inconsistently using the no except marking. Standard runtime actually has several exceptions. For example, if you allocate memory in C, you would just get a null pointer returned. In C++, the runtime throws an exception. The reason for that is, of course, that not having enough memory is a very serious thing. You don't actually know easily how to deal with that. So it throws an exception, and it could just simply break off the application. Another common exception that you might run into, although I hope that you don't, is of course array out of bounds in the std array class or the std vector class or such collections. You'll see in the code on GitHub that I throw exceptions in C++ only if aborting the program is likely the best thing to do. Using try-catch is not wrong, but it's something that you have to be very careful about. In this example, I only did it in main to write out a message explaining why the exception was thrown, because the exception tells us that. Many modern programming languages will actually use this crash by default behavior, saying you can catch them if you want, but if you don't, the program will exit. So today we got most of the basic stuff here. Connecting to the simulator. A connection is identified by a handle, and what that is some kind of pointer. We don't know, we shouldn't care. Good form, therefore, is it to make sure that the handle is a null pointer when there is no connection currently active. Good form is it also to not ignore the success or failure of connecting, because if we have done a call to open and it fails, we'd better do something about it. What we can improve on these basics, of course, is retry on failures. We could say, well, maybe Flight Simulator is starting up, but not yet finished. Or maybe we have the program running on a different PC than the one running simulator and we have a networking problem. Another very interesting approach is to make guarding that connection a background process. If you're writing an application which has a window in Windows, then you might want to do that. This way, you don't need to give the user a button to connect, but you can simply say, I'm going to try to connect, and I'll keep trying. And as soon as I have a valid connection, I'm going to show that somewhere. You can then send notifications, events to the rest of the program about that. Next time, we're going to look at what we're going to do with this connection, namely sending messages to the flight simulator and receiving messages from the flight simulator. We're going to look at the different ways that we can detect and then process incoming messages from flight simulator. And we're going to decouple the message handling from other work that we're doing. We're also going to look at how we can check on the status of the simulator, because the simulator can tell us whether or not the user is currently flying or doing something in a dialogue. We can also get events that tell us when such a state changes. So, for example, we can detect when the user has pressed escape and started doing things and is no longer actively flying around. Then, of course, there are the real simulator events that something happened, for example, the user pressed a button or flipped a switch in the cockpit or something else happened. We're going to discuss what those events are, how we can find out about them, and how we can select the ones that we are interested in. All the sources that I've used today, and also the sources that we're going to use in the other parts, will be on GitHub. You can go to github.com/dutch-flightsim-developer/developing-with-SimConnect. You don't need to write that down. The URL is also in the description below. So then, that's it for today. And as Dave from Dave's Garage says, I'm mostly in this for the subs and likes. So if you feel like it, please leave one of those. You're also free to leave comments, but I can't promise prompt replies on all of those. Thank you for your time, and see you in the next one.